The eternal struggle between life and death. No matter the toil or triumphs faced, sooner or later the reaper will knock. Normally, with every life taken, a new one enters this world, and the cycle continues on. But there are times when the bell tolls more frequently, and death gains the upper hand. Though events like the plague and the Spanish flu were devastating to us humans, they pale in comparison to the mass extinctions haunting the geologic past. For those that do not know, a mass extinction is typically defined as, quote, when at least half of all species die out in a relatively short time, end quote. Though we have to keep in mind that this is geologic time, and in Earth's history there have been 5 of these mass extinctions, so let's talk about them one by one. The first mass extinction was the Ordovician, or the End Ordovician, or the Ordovician-Silurian mass extinction. One thing you'll notice very quickly is that most of these have many names. For today, I'll typically stick to calling them by the period in which they started, or the shortest name. The Ordovician period, which lasted from about 488 to 443 million years ago, was when the life from the Cambrian continued to diversify. It saw plants colonize further inward onto land, and arthropods followed suit, as the first fossil evidence of terrestrial animals is from this period. The land at the time were the supercontinents Gondwana and Laurentia. But how did it end? Well, throughout the Ordovician, Gondwana was drifting south, eventually reaching the pole during the Upper Ordovician. This eventually resulted in ice caps forming over the continental land, cooling the climate, forming glaciers, and causing sea levels to recede. The extinction event itself lasted for about 450 to 440 million years ago. However, it occurred in 2 stages. The first being when the glaciers first started forming as the dropping sea level drained the shallow inland seas and kick-started deep ocean currents, bringing toxic materials from the abyss closer to the surface. The second wave came when the glaciation ended, causing the currents to stop, and the species that had adapted to die off. In the end, about 85% of marine life went extinct, making it the second worst mass extinction in history. Some of the casualties were a few species of trilobites, almost all of the graptolites, and many brachiopods. The next mass extinction was the late Devonian. The Devonian era lasted from 419 to 359 million years ago. Though animals had already crawled up on land, leading to the first amphibians, the diversification of oceanic life earned this period the nickname the Age of Fish. The extinction event actually occurred in 2 or 3 parts, depending on what source you're looking at, each marking the end of a geologic age. The 3 extinction events went as follows: the Javetian extinction, sometimes called the Tagonic event, the Frasnian-Famnian extinction, sometimes called the Kelvasser event, and the N-Famnian extinction, sometimes called the Hengenberg event. Even today, there's still a lot that isn't known about what caused the late Devonian extinctions, with a lot of different and sometimes contradictory theories, ranging from volcanism to comets to a rise in plant life. For brevity, I'll cover what I think is the most likely. The Tagonic event is sometimes counted as part of the late Devonian extinctions and sometimes not, so I'll keep this brief. It began about 384 million years ago, and the extinction was likely caused by a rise in sea level known as a transgressive sequence. This sea level rise continued throughout the entirety of the Frasnian. The 2 main ones are the Kelvasser event, which occurred 374 million years ago, and the Hengenberg event, which happened about 15 million years later, ending the Devonian. The Kelvasser event wiped out a large amount of marine life, and the Hengenberg event affected both marine and terrestrial life. The Kelvasser event, unlike the Hengenberg event, does not show direct evidence of glaciation, so it is more debate regarding its cause. Some sources say sea levels were rising due to deglaciation, with evidence for this coming from the black shales that formed during this time. However, other sources say the complete opposite, that sea levels dropped during this time as a result of glaciation. Personally, I believe the latter is true. The Devonian was when the first forests appeared. This absorbed vast amounts of carbon dioxide, which reduced the greenhouse effect. Yes, there are black shales, which means that the ocean was deprived of oxygen. However, a theory called the Devonian plant hypothesis proposes that this could be caused by the new soil forming as a result of the root systems caused by the rise of vascular plants. This soil caused silicates to be weathered away, which in turn caused CO2 to be removed from the atmosphere by being absorbed into calcium and magnesium carbonates. These would eventually make their way to the ocean through rivers and deprive the ocean of oxygen, forming the black shales. By the end of the late Devonian mass extinctions, between 79% and 87% of all species, most of which were marine, went extinct. Some of the losses were all of the armored placoderms and many species of brachiopods, coral, and trilobites. Next was the Permian extinction. Now, the Permian extinction is my favorite mass extinction, mostly because I like the Permian period. The Permian lasted from about 290 to 248 million years ago. The climate during the Permian was incredibly dry due to the formation of the supercontinent Pangaea, keeping the interior of the continent far from the humidity of being near the ocean. This period saw the diversification of amniotes, which initially evolved during the previous Carboniferous, and their split into reptiles and synapsids. However, the Permian ended dramatically in the worst mass extinction in history. One of the leading contenders regarding the cause of the Permian extinction was massive amounts of volcanism in what is now Siberia. Essentially, 252 million years ago, a plume that had formed under the region melted, causing 2.5 million square kilometers, or about 1 million square miles, of lava to flow, lasting for over 1 million years and creating the Siberian traps. Recent evidence suggests that during this eruption, vast quantities of halogens like chlorine, bromine, and iodine were released from the crust, which caused massive destruction of the ozone layer. This caused a period of global warming, severe enough that water traveling along the Great Ocean Conveyor was no longer cooled at the poles, meaning it didn't sink, which caused the Great Ocean Conveyor to stop. Without the currents, oxygen wasn't moving throughout the ocean and marine life suffocated. From there, bacteria that could get oxygen from sulfur oxide compounds became even more abundant. However, this process produces hydrogen sulfide, which began to saturate the oceans and disperse into the atmosphere. This caused the massive demise of terrestrial life in addition to marine life. In the end, 96% of marine species and 70% of terrestrial life died, resulting in this extinction event's nickname, the Great Dying. Some of the casualties of this extinction were the numerous species of synapsids, including my favorite extinct animal, Dimetrodon, the Eurypterids, which are colloquially referred to as sea scorpions, and the last of the trilobites. The devastation of the Permian extinction brought a close to the Paleozoic era, and the Mesozoic began. The first period of the Mesozoic was the Triassic, which lasted from about 248 to 201 million years ago. As is often the case following mass extinctions, the surviving life began to diversify in order to fill the niches that were left behind. Pangaea still dominated at the start, though near the end of the Triassic, the supercontinent had begun to break up into Gondwana and Laurasia. Additionally, the first dinosaurs appeared during this period, around 230 million years ago, and it's possible that the first mammals appeared near the end of this period. However, this would all come to a close during the Triassic extinction. As I said before, Pangaea began to rift, which resulted in massive amounts of volcanism. This caused carbon dioxide to release into the atmosphere, resulting in global warming. This heating possibly released methane that had been trapped in permafrost, which would have amplified the heating effects. Though this was on a smaller scale than the prior Permian extinction, it still caused about 76% of all species to go extinct. Some of the animals that went extinct during this time were the phytosaurs, the conodonts, and all but one species of ammonoid. Following the Triassic extinction, life recovered and diversified, and eventually the Cretaceous began, which lasted from about 145 to 65 million years ago. And though the Jurassic is typically thought of as the era of dinosaurs, for whatever reason, the Cretaceous also gave rise to some well-known dinosaurs like the horned ceratopsians. But then came extinction. The KPG extinction event seems to be the one that most people know. I imagine that it has something to do with the poeticism of the largest, most fearsome species to ever live being destroyed by a fiery act of God raining down from the heavens. Or it could be that kids like dinosaurs and at some point they ask why they aren't here anymore. Either way, the scientific explanation is as follows. About 65.5 million years ago, an asteroid that was about 10 kilometers or 6 miles wide struck the Yucatan Peninsula, creating a 180 kilometer or 112 mile wide crater. Now, this is massive, but destroying a little over 100 miles of land is far from affecting all life on Earth. The real danger came in the aftermath. The collision would have released massive amounts of dust into the atmosphere, which would block out the sun, and this blocking of sunlight, in addition to the sulfuric acid aerosols it released, would have caused global cooling. Furthermore, when the asteroid traveled through the atmosphere, it would have caused the air around it to heat up, which causes nitrogen oxidation, creating nitric acid, and the collision itself would have released gypsum dust into the atmosphere, forming sulfuric acid. This newly polluted atmosphere would result in acid rain. This could have been the cause of surface ocean acidification, which killed off species of plankton, resulting in a collapse of the food chain. However, there is still debate about this mass extinction. Though we know an impact did occur, some scientists believe it was just one of many causes, one of the most popular being Deccan volcanism, which was the volcanic eruption occurring in India at about the same time as the impact. Some scientists even argue that the asteroid impact caused high-magnitude earthquakes that restarted or intensified the volcanism occurring at the Deccan Traps. Either way, between 60 to 80% of species went extinct, including pterosaurs, ammonoids, mosasaurs, and many dinosaurs. This eventually led to the rise of mammals. Recent evidence has shown that we might be living in a mass extinction event right now. Now, since I study geology, dates with less than 6 zeros aren't really my thing, so I'll keep this quick. The Holocene extinction event possibly began at the beginning of the Holocene epoch around 11,700 years ago, when Homo sapiens began to overhunt Ice Age megafauna. And over the years, more and more species have gone extinct, with likely causes being overhunting, habitat loss, climate change, and a general warming of the planet, likely caused by an increase in low-level ozone and a depletion of stratospheric ozone. Mass extinctions seem to exist as haunting reminders of the fragility of life. They show how interconnected the planet truly is, to where volcanic eruptions in Siberia or an asteroid strike in Central America can have a global impact that lasts for millions of years. However, time marches on, life recovers, looking a little different than before, and a new era begins. Some of the losses were all of the armored placoderms. This process produces hydrogen sulfide, which began to saturate the oceans and disperse. As is often the case following mass extinctions, the surviving life began to diversify in order to fill the niches that were left behind. Is it niches or niches?
Niche.